Welcome! Today we're analyzing how much heat a wall gains in the summer. We'll walk through the given data, imagine the heat moving through a wall, and calculate the sensible load step by step. Here is the situation. We have a south-facing wall that is 30 feet long and 10 feet high, so the total area is 300 square feet. Its overall U value is 0.08 BTU per hour per square foot per degree Fahrenheit. For summer design conditions, the outdoor air is 95 degrees Fahrenheit, and the indoors is 75 degrees. Let's visualize this wall. Here is the wall, and we draw small arrows showing heat leaking from the warm outside to the cooler inside. We label the outside temperature 95 degrees and the inside temperature 75 degrees, so the difference is 20 degrees Fahrenheit. This delta T drives the heat transfer through the wall. Our area is 30 feet times 10 feet, so the wall has 300 square feet. The temperature difference is 20 degrees Fahrenheit, which is what we just labeled. Now we apply the steady-state heat transfer formula. The heat gain Q equals U times A times delta T. We already know U equals 0.08, area equals 300, and delta T equals 20. Let's plug in the numbers. Q equals 0.08 times 300 times 20. We multiply 0.08 by 300 to get 24. Then 24 times 20 gives 480. So the wall's design sensible heat gain is 480 BTU per hour. That corresponds to choice B, 480 BTU per hour. This result aligns with standard references like the NCEES Handbook Section 8 on wall heat gains, as well as ASH, our AE's cooling load calculations.